Hello everyone. This video will cover the slope of a line. Okay, so the definition of a slope is the slant or steepness of a line, which is basically saying how quickly the line increases or how quickly the line decreases. Okay, so let's look at the general idea behind a slope. Okay, so let's say if we have our x and y axis, we have our x here and our y there. Okay, so let's say if we pick two x values, it could be 1 and 5, it could be 3 and 20, it could be any two x values, but we'll just call them x number 1 and x number 2. Okay, we're going to do the same thing with two y values. We're going to call this one y value number 1, and we'll call this one y value number 2. Okay, so the same way, let's say if you had x is 2 and y is 3, this point would be your 2, 3. But here, your point would just be x1 and y1. Okay, and let's say this point here, we'll call this your x1, y1. And same thing here. Let's say if x number 2 was 8 and y number 2 was 5, it would be 2, 5. But this one is point x2, y2. Okay. Now the one way to find your slope, and I'll put it underneath here, to find your change in your y value over your change in your x value. Okay. Now to find your change in your y value, you have y2 and y1, which you can just put right there, since that's your y1 and that's your y2. That's your change in your y value. Now your x1 and x2, that's your change in your x value. Okay, so just think about it this way. If x2 is 5 and x1 is 3, how would you find your change between 5 and 3? You'd subtract it. So if you wanted to find the change in that, you just do 5 minus 3. But in this case, your change in y, since you don't have two numbers, is just y2 minus y1. Okay, so that's your change in y. Let me see if I can focus this a little better. There we go. All over your change in x, which is x2 minus x1. Okay, so this is actually your slope formula. So that's y2 minus y1 over x2 minus x1. Now, if you wanted to, you could make this x1, y1, and x2, y2. It doesn't matter which one you make it. Or you can make it y1 minus y2 over x1 minus x2. Okay. Now, the thing is, you have to go in the same order for each one. See, y2, x2 minus y1, x1. or y1 x1 minus y2 x2. You have to go in that order. Okay. You can't use, let's say, the slope, move that up a little bit, is equal to y2 minus y1 over x1 minus x2. Okay, can't use that. That's because if you go from the order from y2 to y1, you have to do the same thing with x2 to x1, or y1 to y2 and x1 to x2. They have to go in the same order. You can't go y2 to y1 and then x1 to x2. You're switching direction. Okay, so remember, you can't do that. You have to have these in the exact same order. All right. So let's say, for example, and remember, if you're still writing, feel free to press pause. Okay, so for our first example, bring that down a little bit. There we go. Let's say if we wanted to find the slope of the line through the points let's say -1, 5 and 2, -3. Okay, so what they did was they gave you 2 points and they want you to find the slope between those 2 points. Okay, so what I'm going to do is just rewrite those 2 points. Now to solve this, the first thing you do is you assign your x1, y1 and your x2, y2. Okay, so let's say if we make this our x1 and this our y1. So let me clean that up a little bit. That looks, there we go. So we have our x1 and our y1. Let's say this is our x2 and our y2. Put a little comma there. Okay, so we have our x1, y1 and our x2, y2. So remember, your slope is equal to y2 minus y1 over x2 minus x1. Okay, so y2 minus y1 is just -3 minus 5. So you have -3 minus 5 over your x2 minus x1 is 2 minus -1. Okay, so -3 minus 5 is -8. And 2 minus -1 is just 2 plus 1, which is 3. Okay, so your slope is actually -8 over 3. Okay, or let's say if you wanted to use the slope formula, y1 minus y2 over x1 minus x2. Okay, so y1 minus y2 is 5 minus -3 over x1 minus x2 is -1 minus 2. Okay, so 5 minus -3 is 8 over -1 minus 2 is -3, which is the same as saying -8 over 3, because remember, the negative sign in the denominator in front or the numerator is the exact same thing. So you can move it from the bottom to the top and it's still just a negative fraction. Okay, so either one of those formulas will work. Is just a matter of which one you're mostly this is used, but it doesn't matter which one you make your x1, y1 and x2, y2. Okay, so if you want it, you can make this your x2, y2 and this one your x1, y1. You get the same answer. All right. Okay, so let's say for our quick little reminder is that you have a fraction. Your rise is the number on the top, and your run is the number on the bottom. So this just lets you know that the rate that it, in this case decreases, is -8 for every 3 points you move to the right. And I'll show you an example of that a little later on. All right, so for our next example, let's say if we want to find the slope of the line through the point, say -1, -2, and 2, 4. Okay, so those are the two lines through the point. Well, 2 points through the line there. So we're just going to rewrite -1, -2, and 2, 4. Okay, so remember, to find the slope, the first thing you do is you assign your x1, y1 and your x2, y2. I'll make this my x1, y1, and this our x2, y2. Let me clear up that 2 a little bit. There we go. And make that a little clearer. I don't want any confusion for anyone. There we go. It looks more like a 2. Okay, so you have your x1, y1 and your x2, y2. So now you just plug it in. y2 minus y1 over x2 minus x1. Okay, now remember, your y2 minus y1 will always be on top. Okay, that's the one mistake you want to make sure you don't make, is not putting the x2, x1 on top. You can't do that. You have to have the y2 and y1 on top. Okay, that's always going to be in your numerator. Okay, so you have 4. Your y2 minus y1 is 4 minus -2 over your x2 minus x1 is 2 minus -x. 2 minus -1. Sorry about that. Okay, so 4 minus -2 is the same as 4 plus 2, which is 6. And 2 minus -1 is the same as 2 plus 1, which is 3. So your slope is actually 2. Okay, so you have a slope of 2. Okay, or if you wanted to, you want to make your slope equal y1 minus y2 over x1 minus x2, you can do that also. Remember, it has to be 1 minus 2, 1 minus 2. You can't switch them around. So y1 minus y2 is -2 minus 4 over x1 minus x2, -1 minus 2. Okay, so -2 minus 4, that's going to give us -6. And -1 minus 2 is going to give us -3. Negative divided by negative is positive, so you end up with +2. Okay, now as far as your rise over run, even when you have a whole number, Remember that 2 is just 2 over 1. Where your rise is equal to 2, that's how many spaces you move vertically compared to how many spaces you move horizontally. All right, so this next example is going to show us how to apply the rise over run. Okay, and we're going to do that a little bit differently. Okay, so let's say for this example, find the slope of the line. And instead of giving you 2 points, I'm just going to put this line there. Excuse me. Okay, now in this case, let me fold this, give me a little more room to write underneath it. There we go. Okay, so whenever they give you just a line, the one thing you want to do is you want to find 2 points that are right on the corner. So you want to look on the line and find, okay, where can I find a point that's right on the corner? Okay, so if you look right here, that point is right on the corner. So you know for a fact that that's, let's say, -1, -2. And if we go up 9, right on that corner is -2, 9. Okay, so we have, oh, better yet, let me put the instructions there. So pick any 2 points that intersect at a corner of the graph. Okay, so again, if we notice here, we know -2, 9. Okay, so we have -2, 9. Uh-oh, sorry about that. Actually meets right at that corner. Okay, so that means we have -2, 9. And if we look closely, we'll see right at this point here, we have 7, -1. So right at that point, we have 7, -1. Okay. Now you could have picked any number of points on here that meet right at a corner. Like, well, you know this point right here doesn't meet at a corner. It's right between 1 and 2, and it's right between 4 and 5. You want to pick a value that meets right at a corner so you can identify what the point is. Once you find your 2 points, you just apply the same formula that we did before. Okay, so we move that up. So we make this our x1, y1. And we make this our x2, y2. And we plug it right into our formula. Okay, so the slope is equal to y2 minus y1 over x2 minus x1. Remember, your y values always go on top, and it just has to be in order. The second minus the first, second minus the first, is equal to y2 minus y1 is -1 minus, well, -1 minus 9. Sorry about that. And your x2 minus x1 is 7 minus -2. All right, so -1 minus 9 is -10. And 7 minus negative, remember that minus negative becomes plus. 7 plus 2 is 9. Okay, so our slope for this one is negative 10 over 9. Remember, that's our rise over run. And I'm going to explain what rise over run means. Okay, so if we go right back up to our graph, your rise can be positive or negative. Let me go up a little bit. There we go. Your rise can be positive or negative. That just means you go up or down. Okay. Your run is always going to be positive because you're always going to go to the right. Okay, so let's say if we start at our negative 2, 9. And move this down a little bit. Okay. Remember, your slope equals negative 10 over 9. So how does that apply to rise over run? I will show you. Okay, let's say if we start at any point on the graph, we're just going to pick this point, our negative 2, 9. Our slope is negative 10 over 9, or rise over run. So since our rise is negative, we're going to go down 10 spaces. Okay, so we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we end up at negative 1. Now our run is 9, which means we go to the right 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. What do? We ended up right back on the graph. Which means if we go down another 10 spaces, if we go down another 10, and then to the right another 9, we'll end up right back on the graph. If we go down another 10, then go back over another 9, we'll go right back on the graph. That's the rise over run. If you just repeat that negative 10 over 9, no matter where you start, if you start right here, and if you go down 10 and over 9, you'll end up right back on the graph. That's where the rise over run comes in. Okay, so to give you another quick example of rise over run. Okay, so let's say if you have your graph here, you have your X and you have your Y. 1, 2, 3, 4. 1, negative 2, negative 3. Let's say 1, 2, 3, 4. 1, negative 2, negative 3, negative 4. Let me clean up that 4 a little bit. There we go. All right, so we have our basic graph. No points yet. So let's say if we have, let's say if we start starting at the point 1, 1. Graph a line with a slope of 2, positive 2. Okay, so what we have here is we have a point, and they gave us a slope. And they want us to graph this line. Okay, so all you have to do really with this is remember that 2 equals 2 over 1, which is your rise over your run. Okay, so if we start at 1, 1. If we rise a positive 2, so if we rise up 2, and our run is 1, so that means we go to the right 1, we have our second point. So if we go up 2 more, and our rise is 1, we have our third point. If we go up 2 more, and our rise is 1, we have our next point. So we have all of our points that we will need. Really, you'll only need 2. So once you get all of your points, you just grab a flat edge, or most of you will be using the online homework. And that's your line right there. Of course, I'm doing it by hand, so it's not as even as it should be. But that would be your line, starting at that point and knowing you have a slope of 2. So, of course, drawing it by hand is not as precise as you would like it to be, but you get the idea. Okay, so hopefully the rise over run makes a little bit of sense to you. All right, so now we're going to go over what we call the slope-intercept form. Okay, so we have our slope-intercept form. Okay, so really the easiest way to explain finding the slope-intercept form of a linear equation is to solve for y. That is literally all you have to do. You have to solve for y. Okay, so if a linear equation is solved for y, the coefficient of x, well, let's say the x term, of the x term is the line slope. Okay, so if you have a linear equation and it is solved for y, the coefficient of the x term is the slope. And how that looks is y equals m times x plus b. Okay, and all of those values have a meaning. This m is the coefficient of the slope. So whatever number is next to that next to that x is your slope. So your slope equals that m value. Okay, and this b is what we call your y-intercept. Okay, now if you remember, you find your y-intercept by making x equals 0. So if we make x equals 0, whatever that number, that slope is, doesn't matter. X equals 0 wipes out that entire term. So you end up with y equals b. So your y-intercept would just be when x is equal to 0, y is going to equal whatever that b value is. So that's how your y-intercept will look. Okay, so you actually have your slope and y-intercept, which is why they call it the slope-intercept form. All right, so we're going to go over a few examples here. Okay, so let's say, for example, we want to find the slope and y-intercept for y equals 4x plus 9. All right. So to find that, we have y equals 4x plus 9. Remember, that's in the form. I'm just going to put that y equals mx plus b. That's the slope-intercept form you're looking for. So since the value next to the x is m, the value next to the x up here is 4. That means your m, which is your slope, equals 4. And remember, your b is your y-intercept. Okay, so that means b equals 9. So your y-intercept is 0, 9. Okay, so we have our slope and we have our y-intercept. Okay, so you can pick it all out right there. All right, hopefully that made sense. It's pretty straightforward. Okay, but what if we had an example that looked a little bit different? Let's say, for example, we want to find the slope and y-intercept for negative 2x plus 3y equals 11. Okay, so these are the ones you have to be really, really, really careful. Because let's go back a little bit to what we said about finding the slope. We go back to our last page. Remember, the linear equation is solved for y. That's the key right there. It's solved for y. Then the coefficient of the x term is the slope. So if you just come up and automatically say the slope is negative 2, you'd be incorrect because this is not solved for y yet. Okay, so you can't just automatically go to the x and say, oh, the slope is negative 2. Let me go to the next one. It will say it's incorrect. Okay? So the first thing you have to do is solve for y. All right, so if we have negative 2x plus 3y equals 11, then we go ahead and add 2x to both sides, where that cancels out. So that gives us 3y equals, remember for slope-intercept form, the x term comes first. So instead of 11 plus 2x, you put 2x plus 11. Okay, so now we have to get the y by itself, which means we have to divide each term by 3. So we divide this one by 3, we divide this one by 3, and this one by 3. Okay, so whatever you do to the left, you have to do every term on the right. Okay, so you can't just divide this one by 3 and this one by 3. You have to do all the terms the same way. Okay, anything divided by itself is 1. So that means that y is equal to 2x over 3. If you want, you can just bring that x to the front. So you have 2 over 3x plus 11 over 3. Okay, so if we match this up with our slope-intercept form, remember y is equal to mx plus b. We see that the term next to the x is 2 over 3. So we know that m, which is our slope, equals 2 over 3. And we see also that our b is equal to 11 over 3. So that means your y-intercept is 0, 11 over 3. The point 0, 11 over 3. And let me clean that 3 up a little bit more. There we go. Okay, so we have our slope and we have our y-intercept. Okay, so remember, always, always, always solve for y first before you look for your slope and y-intercept. That's a very important step. All right. So let's look at a few other examples of the slope. A little sheet there underneath it, running out of paper. Okay, so let's say, for example, we want to find the slope of y equals -1. All right, so first I'm going to show you how to find the slope, and then I'm going to show you a shortcut for when it looks like this. All right, so we know that y equals -1. You can rewrite that as y equals 0x minus 1. Remember, that's just 0 minus 1, which is just -1. All we did was rewrite it. And again, this is the explanation version of it. The shortcut will be a whole lot simpler. Okay, so bear with me a little bit. All right, so now let's say if we decide to graph this. We have our x and we have our y. Okay, so let's say if we decide to graph this, so we'll let x equals 0 and x equal 1. So when x is equal to 0, 0 times 0 is just 0, so y is still -1. So that gives us the ordered pair. When x is 0, y is -1. And when x is 1, 0 times 1 is still 0. So when y equals -1, oh, not y is equal to 1. Yep, y is equal to -1. There we go. So when x is equal to 1, y is equal to -1. There we go. All right, so we're going to go ahead and graph this. So we have our x, we have our y. Let's say this is 1, 2, 1, 2. Let's say -1, -2, and we'll just go down to -1 here. Okay, so if we plot our 0, -1, x is 0, y equals -1. And when x is 1, y equals -1. Remember, you plot 2 points, and then you just draw a line through your 2 points. And this is your graph of y equals -1. Okay, now we have our graph. Now we're just looking for the slope. Remember, your slope is y2 minus y1 over x2 minus x1. Okay, so make this our x1, y1, and x2, y2. So we'll make the x1, y1, and this one our x2, y2. Just like we did before, nothing really changed there. Okay, so y2 minus y1 is -1 minus 1 over your x2 minus x1, which is 1 minus 0. Okay, so we have -1 minus 1 is 0, and 1 minus 0 is 1. So 0 divided by anything other than 0 is just 0. Okay, so for this one, the slope is 0. Okay, but here's the shortcut I was telling you about. And instead of shortcut, I'll just write that as a note. Okay. Okay, so using the shortcut I was telling you about, in general, y equals, let's say, any number k where k is any number, will always have a slope of 0. Okay? So if I ask you to find the slope of y equals 20, it'll be a slope of 0 because it's just a horizontal line through 20. If I ask you to find the slope of y equals 18, it'll be 0. If I ask you to find the slope of y equals 3,847,000, you would, I don't know, whatever it is, how big the number is, it will always have a slope of 0 because any straight line going from left to right with no slope, it's just a slope. It doesn't go up, it doesn't go down, it's just a straight line across. Okay? Alright, so let's go to our next example. But remember that value there. When ky is equal to any number, we'll always have a slope of 0. Alright, so we'll go to our next example, which is really similar to this one, but a little bit different. Alright. More paper here. Okay, so let's say, for example, we want to find the slope of x equals 4. Alright, so just like before, I'm going to do the explanation version, then I'm going to do the shortcut, because it's a shortcut for this one too. Okay, so we know that x equals 4 is the exact same as saying, I have to put the x first, x plus 0y equals 4. Because 0 times y is 0, so that's just x plus 0, which is x. So it's the exact same thing. Okay, so just like we did before, we're going to make our table where we have our x and we have our y. Okay, so before we made x equals 0 and x equals 1. Here we're going to make y equals 0 and y equals 1. Just two values. Could have picked any two values, but we're just going to pick those. Okay, so when y is equal to 0, you have x plus 0 times 0 equals 4. All we did was make y equals 0. 0 times 0 is 0, so that leaves us with x equals 4, which gives us the ordered pair of 4, 0. Okay, now when y is equal to 1, that gives us x plus 0 times 1 equals 4. Which, again, 0 times anything is just going to be 0, so that gives us x equals 4. So that gives us the point 4, 1. Alright, so just like the example we did before, we're going to go ahead and graph that really quick. Okay, so we have our x-axis and our y-axis here. So we have 1, 2, 3, let's say 1, 2, 3, 4, -1, -2, and let's put a -1, -2 over here, just to keep things balanced. Okay, so we have our graph here. So if we plot those 2 points, so we have 4, 0, x is 4, y is 0, so our 4, 0 is right there. If we go 4, 1, x is 4, y is 1, so we go 1, 2, 3, 4, 1, right there. And just like we did before, we get our straight line through the points. Alright, so we go ahead and draw the line through there. And that is the graph of x equals 4. Alright, so it's pretty simple. Remember, x equals any number is just a vertical line through that number. So this is the graph of x equals 4. But we don't want to graph it, we want to actually find the slope. So remember, your slope is equal to y2 minus y1 over x2 minus x1. Okay. So just like we did with the y, we just make this our x1, y1, clean that up a little, and this one our x2, y2. Okay, so now we just go ahead and plug it in. Okay, so y2 minus y1, you have 1 minus 0. And our x2 over x1 is 4 minus 4. So 1 minus 0 is 1, and 4 minus 4 gives us 0. Now remember, 0 divided by any number over 0 is 0. But when your 0 is in the denominator, you can't use it. The 0 in the denominator is actually undefined. So whenever you have a 0 in that denominator, you have an undefined slope. All right, but you don't have to go through all this work when you have x equals anything and you want to find the slope. Okay, so note, in general, when x equals any number k, so remember k is any number, the slope is always undefined. Okay? So that means if I said find the slope of x equals 8, I don't have to do all this. I automatically know it's undefined. If I say find the slope of x equals 24, I don't have to write anything down. I know it's undefined. They say find the slope of x equals -3. I don't have to write anything down. I know it's undefined. Automatically without writing down a thing. Okay, so we're going to visualize our slopes here, and then that will be that. Oh, let me separate these. There we go. Okay. So we know that positive slopes go up and towards the right. Okay. So for example, you will have let's say that's your x-axis and that's your y-axis, that graph, that line would have a positive slope. Or let's say if you have your x-axis and y-axis here, you have, let's say this one, that graph has a positive slope. It's going up and to the right. Okay, so every time you have a positive slope, let's say it could be positive 10 over 3 or positive 8 or positive 92 or whatever the slope is, it's going to go up and to the right. Your negative slope, however, they go down and towards the right. Okay, so that means draw a couple of XY axes here. You have your X and you have your Y. You have your X and Y. So that means this slope is negative because it's going down and to the right. And also this slope is negative because it's going down and to the right. Okay, so you have up to the right, down right, down right. Okay, now you can also, from the previous two examples, we know that slopes of 0 are horizontal. Not to say go horizontally, but just are perfectly horizontal. Okay, so that, let's say, for example, this is our x-axis, this is our y-axis, and this is the graph of y equals 8. Okay, perfectly horizontal, left to right. Slope of 0. Or, let me finish that up, there we go. We have our x and we have our y, and let's say if we graph y equals -3. Okay, that particular line is the graph of y equals -3. Slope of 0 because it's perfectly horizontal. It doesn't slope up, doesn't slope down, just perfectly left to right. Okay? And last but not least, let me move this up a little bit. Here we go. Undefined slopes are perfectly vertical. All right, so let's say if we draw a couple of our XY axes. Okay, so we have our XY axis here and here. Okay, so let's say if we want to graph x equals 9. Remember, that's just a line right through 9. That's an undefined slope because it's perfectly vertical. Okay, same thing here. If we wanted to graph x equals -2. Okay, so x equals -2. Again, undefined, perfectly vertical. Okay, so that's kind of a breakdown of how your slopes will look. All right, so hopefully this has helped you out, and I will see you on the next video.